Okay, good evening, everyone. Um, this is my YouTube stream home screen for those of you that really do not know about it. Probably someday you'll learn about it too. Today, we're going to be doing something very simple. I promise that we'll be learning about object-oriented programming in JavaScript. So first and foremost, what is OOP? What is object-oriented programming? Object-oriented programming is all about writing programs that simulate real-life objects. It just hovers around objects. Understand? Just like objects in real life, they have properties, and behaviors. So also we write programs that define this object that has properties, and in programming we don't call it behaviors, rather we call them methods or functions, which define how actions to be performed by a certain object. One thing to note is that all objects are unique, no matter how precise they are. Like if I tend to make two different cups, for instance, and I give them same design, I use same quantity of clay or whatever, I paint them precisely the same way, they are still two different objects, they are not the same object. So also it is in programming. Every object is distinct. Very important to remember that every single object is distinct. So whenever we talk about OOP, object oriented programming, something comes to mind, or a few things or a few concepts comes to mind. That is abstraction, polymorphism, inheritance, and encapsulation. I'm not really going to lay emphasis on these four concepts of OOP, but I would recommend that you try as much as possible to learn about them if you can. But I'll just narrow to this class to just JavaScript. Also, objects is an entity that you can interact with in your program. So when you have these elements that you can actually interact with, that you can call, you can change values of, those kind of interactions where we term them as object. Whatever you can actually interact with is an object. So objects are also termed as instance of a class. As well, we can say that a class is a blueprint of an object. The object is an instance of a class, while the class is a blueprint with which an object is built. You understand the difference here? Now, objects can be something like Toyota, for instance, Toyota car, a specific kind of car. You understand? The class could be car, but the object could be a particular brand, a specific one. You understand? So what we're going to do today is just OOP. You're just going to keep doing the how we implement these OOPs in JavaScript. Okay, I think I just made a mistake by opening VS Code, but no problem. Let's move on. This is a project I'm actually working on at this point in time. It's for a client on Upwork. I'm not through with it, but hopefully I'll finish it by the end of today. So remember our JavaScript folder that's on my desktop. Yeah, yes. So I'm going to create a new folder in here. I'm going to call it OOP, and then select that folder so we can start up a new project. Okay, alright, so you know the drill. I'm very sure you know the drill. We have our index.html, and then there's app.js, and those are the only two things we need. So I can start up a boilerplate code by typing !tab, and then in here we just put an h1 tag OOP, and then underneath I'll link my script tag, set the source attribute to app.js, and then close it. That's pretty much it. All that is left is to open this in the browser. And so if I press enter, my default browser kicks off, Then dev2, remember Ctrl Shift I, or you click this icon right here, more tools, and then developer tools. Very simple. Okay, it's easy to get to. So let's go to the console panel. At this point in time, there's no instruction there to execute. So if I go to my JavaScript file and do a console.log just to test if everything is working just fine, sorry about that, and then I refresh, we get hey the so JavaScript is properly linked to the HTML. Now I'm very sure you remember how we defined objects before. Now I did a little bit of objects in our previous class where we used the object literal and the object.create to, or rather the use object.create or and the object constructor as well as the object.create to create object literals. So I can just do const, let's say John, set this equal to curly brace, set name colon, not semicolon, to John, and this is an object. I've created an object. So some of you have seen this before. It's that simple. If I do console.log John, save, go to the browser and refresh, you see we get this. Now to prove that this is an object, I can still do console.log type of, then John. Remember what the type of operator does? Yes, I believe you do. And so we get objects, understand, which means that the value we pass to it is an object. But we're not going to be treating object literals, rather we're going to go with a more standard approach with creating objects. Before you create objects, you have to create a class. Remember, a class is a blueprint of an object. It's what defines how the object would actually look like. It's just like the blueprint or plan of a building. It defines how the structure is meant to be. You understand? So we're going to create classes and then instantiate the classes. Remember, object is an instance of a class. And so what are the ways to create classes in JavaScript? We have the class declaration, class expression, and function constructor, which is ES5. Remember, I said I won't throw light on ES5 syntax. I will not discuss about it. All what I'll be doing is just ES6. So, but I'll get to a part where I'll actually have to use the function constructor in order to explain something to you. But anyhow, let's proceed. So the first one is the class declaration, and it's that simple, very simple. You just use the keyword class and then specify the name of the class, let's say animal, and then we do constructor which will accept a name, and then this dot name is going to equals name. Now this dot name is going to tie a property called name to the instance of this class animal, and then this parameter here is going to be passed in at the point of instantiation of this class. And so once we pass it in, we use it to initialize the variable. You understand? Okay, so let's try it. I can do const dog set to new animal and passing dog. You understand? So this is instantiation. We're actually wonderful. We're actually instantiating the class animal, and then if you notice, we passed in a string here, dog, right? This string is what this name parameter would accept and to be used to initialize a variable within this guy, not the class, but the instance of the class. You understand? The new keyword changes the reference of the this keyword. The new is used to set rather the reference of the this keyword. So when we said new animal, we are simply saying point the this keyword to this instance right here. So if I do a console, not that, log dog, you save, go back to the browser, refresh, you see we get animal name dog. The reason why this is being displayed here is to tell you the class with which the object was defined of. That's why it's displaying there. One of the interesting things about using Google DevTools. Okay, so we've actually successfully created an instance of a class using class declaration. So another way to define classes is class expression. Remember the class expression. So we've done this. So let's try the class expression. Now this is like it's like function expression. If you remember function expression, it's just simply initializing a variable with a function. Similarly, it is just initializing a variable with a class. So I can just do const person and set this equal to a class, and then put our constructor as always, accept a name, and then we set this the name equal to name that was passed in. So this is using class expression, while this is class declaration. Now similarly, I can create an instance of it, let's say John, and set this equal to new person, and then pass in John. That simple. And as always, we just simply console.log John. If I save, go back to the browser and refresh, you see we get two objects in console. One is of class animal and the other is of class person, and they both have name properties within them. Okay. Now you see the difference between class declaration and class expression. Okay, now they both do the same thing, but then for class expression, this class which we use to initialize this variable here can either be named or unnamed. At this point in time, it's unnamed, it doesn't have a name. I can actually give it a name. Let's say before that, the name of a class, you can access the name of a class from the dot name property. If I do console.log person dot name and then save, refresh, you see we get person right here, because that's the name of the class. Now since this class here is unnamed, it will take this as its name. But if I give it a name, let's say I call it person2, and save, go back to the browser, refresh, you see we get person2 right here, no longer just person, because the class now has a name. So class expression can use both a named or an unnamed class to define the class which will be initialized into the variable. I believe you're following. Yes, of course. Now the this keyword is crucial. It's important in OOP. Understanding this keyword is in fact, if you have strong understanding of the this keyword, you tend to know your way around a lot of things in JavaScript. This keyword is one of the most complicated things in JavaScript, but I'm going to discuss it in as simple as possible. I'll find the basic way to explain the this keyword. Now, I mentioned previously that the new keyword which I use here or every other place where I instantiated the class, the new changes the reference of the this keyword. It points the this keyword to a particular variable. Understand? So this keyword upon instantiation points to this guy. You understand? So normally we can simply use the um, the name of a variable directly, or name of the object directly, just like we do with object literal. But then it has its own pitfall. So let's say I do something like this, const car, and set this equal to an object. Let's set the color to red, and then set the manufacturer to Toyota, and then we define a function, or rather a method called drive, and set this to a function. All it simply does is console.log driving, and then I save. Come underneath, I can simply do car dot drive, right? And then save, go to the browser, refresh, we just get the log driving. Now let's say I want to use properties that relates to this class. I can simply say let me change this to template literal, and I believe you guys may not know about template literal. It's backticks. You use double backticks. It's at beneath your escape key. I don't know your keyboard, but it's called backticks. That's how you write the template literal, and it allows us to actually concatenate strings easier in JavaScript. So I'm going to say driving the $ curly brace car dot color $ curly brace car dot manufacturer car. And then if I save this, go back to the browser and refresh, you see we get the message driving the red Toyota car. Understand? So that's because I'm referencing this property as well as this B, using the object directly. Now this code is not reusable. I can't use it somewhere else. What if in a scenario where I do const bike, for instance, the bike still has color, let's set this to black, and then and then manufacturer to Mura, assuming they now manufacture cars, bikes. Alright, so and then let's say I just copy and paste this here. This won't work. If I save, go back, refresh, you see it's still going to reference the car. It's pointing to this object rather than this one. Understand? Because we are still using car.color. In order to make this more generic so that you can use it under different circumstances, you just simply change this to this. That's all. So this keyword here points to the bike. You understand? So if I save this, go back to the browser and refresh, you see we get driving the red Toyota this. That's because I changed this as well, which is not supposed to be so, and this is supposed to be bike. And then I can call bike dot drive, save, refresh. Driving the black Toyota Zimora bike. Okay, I even forgot to call this method to test it. So if I change this to car like it was before, car, and save, refresh, you see it's referencing the previous object. So if I revert it back to this to reference the bike, object. So you understand? So the this keyword points to the object that references it. Understand? So it points to the object or environment where it is being referenced or where it's being called. Understand? But that's not the case. If we change this to an arrow function, there will be problem, very big problem. If I save this and refresh, you see we get undefined here, undefined. That's because this keyword at this point has not been set. The arrow function does not create it does not have its own scope, does not create its own scope. It uses the scope of the outer environment, and unfortunately this is assigned by whoever calls this function. Whoever calls the function receives the this keyword. Understand? But then, since this guy does not have a scope, this guy cannot be set. Not really does not have a scope, but does not create a context for the this keyword to be initialized. It will be undefined. You understand? Okay, moving on from the this keyword, let's talk about the static keyword. Understand? Static keyword is used to create static properties and methods. By the way, this is a method. When you attach a function to an object, it is called a method. Okay, so let me comment all of this out, and then scroll so you can see. So static keyword ties a property or a method to a class such that instances of that class do not inherit that property. You understand? So if I say class, let's say person, and then I do static count, set this to 0, and then I do name, and let's just do constructor accept name, and then do this dot name is equal to name, and then after that I can do counter plus plus, and thereafter if I do create a John instance, set this equal to new person, passing in John, and then if I try to reference the count, let's say console.log John dot count, this won't work. If I refresh, you see we get count is not defined at new person. You understand? It won't work. It won't be able to have access to count. But then if I do a console.log here person, which is the class itself, dot count, then save, go back, refresh. Okay, I need to take this out. Let's comment this out, save, refresh. Where is count not defined? Did I spell it wrongly? Oh, I made a mistake here. This is supposed to be this count, but I don't think that's the problem. Save, go back, refresh. We get 0 right here. That's because count has been increased. This is a pre-incremental. It produces the result before its increment. Let's do count is equals to this dot count plus 1. If I save, go back, refresh, still get 0. The value is not changing. Why is that? Let's create another instance. Let's see. const Mary is equal to new person, then pass in Mary, save, refresh, it's still 0. Okay, so the value of counts cannot be modified, as you can't really make adjustments to the value of the variable count. You understand? Yes. Now another way we can actually use this is also with methods, not just properties. Now before I proceed, count, or rather static properties, are used for things that you do not want instance of the class to inherit. That's one. Things like caching, when you want to develop system that has to do with caching of values or assets, you use the static variables, because then you know it's only the class that can actually reference those properties. So let's try it with a method. Now to accomplish this, we're going to create a class called point. We're going to create a class. We're going to solve a little problem, and it has to do with distance, measuring distance. So we have name rather let's just start with the constructor going to have x and y axis, then set this dot x equal to x, and then this dot y equal to y, and then we create a static method called calc distance, and this is going to take in two objects, x and a and b rather, and then remember the formula for calculating the distance between 2 points, right? It's simply the square root of x1 minus x2 all squared plus y2 minus y1 all squared. So we'll simply return math.sqrt, which is to find square root, and then do math.pow, which is to raise something to power. Then in brackets we do the x minus b the x comma 2. This might seem a little bit daunting because of the way I'm writing it. Math.power, then b dot y minus a dot y. Remember, order doesn't matter because of the square. So I think I made a mistake here. I need to wrap all of this in parentheses again, then 2. Okay, so I think that is pretty much it. Square root of the square of the difference between x1 and x2 plus this other one. I don't know what to say. Alright, so that's the static method that actually computes the distance between 2 points. So we can now create instances of the class point. I can say p1 is equal to new point, and then passing 12,6 as coordinates for that point, and then const p2 going to be equal to new point, let's do 4,5, and then I can simply console.log point. Remember, we're calling the class, so if I save this, go back to the browser and refresh, you see we get this. So this is the distance between point A and point B. Any confusion? No, I believe you are not confused. We're all following along. Yes. Okay, so there's actually a shorter way to do this thing, which I actually discovered today when I was doing some extra research on the course today. So there's a predefined function, let me just comment this out so the code is visible. It's still there. There's a predefined function. If I do, okay, sorry about the connection error. I was getting a call from somebody. Okay, so if I save this, okay, sorry about the disconnection once again. The call is still coming through. Wow, I never knew I'm this important. Okay, so this is simply a shorthand for this instance. Yes, so you can just maybe store this difference in a variable and then pass it in as two different values, because all this guy actually accepts is two values that it will square. It will find the square of their difference and then take the square root. Just exactly what we did right here. That's what this guy would do. Never knew JavaScript got to that point. Anyhow, okay, so far we've been using public fields. These properties that we define here are actually public. Understand? They can be accessed outside the class. Okay, so moving on. Public fields. So some of these properties, or all of these properties that we've defined so far, are public. For instance, if I do a class called I don't even know what I have defined above, so I don't get a conflicting class. Let's say animal. I can put a name, set this to an empty string, and then do I don't even know what to do again. But anyhow, let's put a constructor here that accepts a name, then set this dot name equal to name. So this is one thing about public variables. They allow us to, we can actually set an initial value for the property before it is actually initialized. So this is a property right here, and it is that same property that is being referenced using the this keyword here. Understand? But then it already has a default value, which is an empty string. So if during initialization I don't pass in a name, I don't pass in anything here, this will be used for the name. So in order to test it, I can just do I don't know, spike, for instance, and then if I do const dog is equal to new animal, close, and then on another line the console.log dog. If I save, refresh, animal has already been declared. Suspected. I knew that was going to happen. So save, refresh, the name is undefined. Wonderful. Or rather I can set a value such that if I don't do this, it will have a name. My bad. I'm having I don't think I'm in my right state of mind. Hunger the hammer the boy. Okay. So if I don't initialize it, it already has a predefined value. So when I do this dot name is equal to name, then I can simply pass in bingo. I think that's a common name here for dogs in Nigeria. Okay, save that, go back, refresh, we get bingo right here. Okay, that's for public fields. Now public fields in the sense that I can still do dog.name out here. If I save, refresh, you see we get bingo. I can access that property from anywhere. That's what it means for it to be public. Now for us to create private properties, it's public properties in this case can be ignored. Like here, if you notice, I didn't put x or y here, I just did them right inside the constructor. But it's not same for private properties. Let's say if I want to define a private property, I have to begin with the hash symbol. Yes, it has to be the hash symbol, and you have to define them before you reference them, unlike the public where we can just reference them and automatically they are available to us. You have to define before you reference. So I can do hash let's call it has built. Okay, and then in here we say this dot hash has built is equal to true, because I don't want to start passing any more values into the variable. Okay, so this dot hash built is now true. So if I log the dog to the console, you see has built is still here. It's a property of the object. But if I try to do dot has built, oh my goodness, has built, if I try to reference it, and then you see we'll get an error. Understand? Private field must not be declared in an enclosed class. So it's private, I can't call it outside the class. You can do that within the class, but you can't outside the class. Understand the difference, right? Yes, I believe you do. Okay, so moving on, the last thing we're going to discuss about OOP is inheritance. Now, inheritance is the ability to reuse code, reuse classes. Instead of repeating a certain class over again, we just inherit from an already existing class and create a new class. So inheritance allows us to create a new class based off of an old class. You understand? For instance, we have this animal class right here, and then I want to create I can take this off as well as this, and then I want to create another class based off of animal class. Let's say the dog class, for instance. I can do class dog extends animal curly brace. So technically this dog is going to implement things from the animal class, but that's not all. So constructor is going to take in a name. The constructor of this dog class is going to take in a name, but then we need to initialize the name property from the animal class, and to do that we call super passing in name. This keyword super would invoke this constructor. Constructor is just simply a special function that is invoked upon instantiation of a class. You understand? Yes, I know you understand. So this super here is going to invoke the constructor of the parent class. So this is a subclass. Dog at this point in time is a subclass. Animal, on the other hand, is a parent class. So calling super, we call this guy and pass this name into the constructor right here. You understand? And by so doing, that will make the name property also available within the dog class. So I can just do bingo, which is going to be equal to a new dog passing in bingo, and then if I console the log bingo, save, refresh, you see it's of the dog class. Understand? But then it's coming from, it extends the animal class. So this is how we establish inheritance in JavaScript. So I've discussed from what objects are, classes, what many nonsense and rubbish, plus static methods to static properties, object literals, and also inheritance. So this is just basically it about, or rather this is just the fundamentals of OOP in JavaScript. Okay, so I really thank you guys for joining me in this class today. I really appreciate you, and do have a nice day. Thank you very much.